Hello. Today we're going to be solving quadratic equations by graphing. So first up here, we're going to check out this quadratic function, f of x equals 4x minus 3x squared. We want to know if this is going to have a maximum or a minimum value. So that is all based off of the a value. So looking at this, our a value here is negative 3. Careful with that because the a always goes with the x squared, which means the b value here is 4. So since a equals negative 3, that means my graph is going to open downward, and this value up here is actually going to be a maximum. So then we want to actually find the maximum value. So looking at this one, we are going to do x equals negative b over 2a, because finding the maximum or minimum is a fancy way of saying find the vertex. So b in this case is 4. It's going to be a negative 4 over 2 times a, and it's going to be 2 times negative 3. When we reduce this fraction, it's going to end up being 2/3. So we're going to go ahead and actually find that value, and this once again would be on a no calculator portion. So we are going to take 2/3 and we are going to plug this in. 4 times 2/3 minus 3 times 2/3 squared. Now, order of operations says that we have to square 2/3 first. And we also can at the same time multiply over here because it's not going to change the other one. So we're going to get 8/3 minus 3 times, and we're going to square the numerator and the denominator, which makes it 4/9. And then that's going to reduce. So we have 8/3 minus 4/3. So our vertex here would be at 2/3 comma 4/3 when we get those together. So the maximum value is just how high this graph is going to go. So the maximum value would be 4/3. Okay, so we have been graphing things from standard form. So standard form is ax squared plus bx plus c for a quadratic function. So now what we're going to do is we're going to take that, and instead of saying y, we're going to say 0. And so if we were to solve this, what we could do is we could solve it by graphing. And when you graph it, the solutions are going to be known as the roots, which is kind of what we were talking about yesterday in our notes. This also happens at the zeros. So the solutions are really the x intercepts of the graph. So if we're able to graph it and find the x intercepts, that automatically tells us the solution to the equation. So let's take a look at number 2 and see what happens here. So we have this quadratic equation equals 0. We're going to try to solve it by graphing it. So we're going to first find our vertex. We're going to do x equals negative b. So that's going to become a positive 3 over 2a. Now a in this case is 1. So our vertex is going to be at 3/2 comma something. So we're once again going to plug this in. So we're going to do 3/2 squared minus 3 times 3/2 minus 4. So this is going to give us 9/4 minus 9/2 minus 4. And then simplifying this, we're going to multiply each of these by 2. So we actually have 9/4 minus 18/4. That's negative 9/4 minus 4. And so combining these together ends up giving us negative 25 over 4 for my y value. So 3/2 is about 1.5, and then negative 25/4 is about here. Now for this one, my 1, 3, and 5 pattern is not going to look nice. So if I go over 1 and up 1, then over 1 and up 3, and then over 1 and up 5, I end up getting something like this. One more. And so this, sure, this is a rough sketch, but it's all based off of like those half values and everything, so it's not the nicest. I also could make sure that my y-intercept lines up nicely because it should match my c value. And then I could reflect that over here. And as you can see, I did not do the best job graphing. So we need another way, because how are we supposed to know where these roots are? So looking at this, we can see that there are two solutions, but we can't see what they are exactly because I did such a poor job graphing it. So since we're looking for the solutions, which are the x-intercepts, what we can do is go back to things that we know. What we know is we actually can factor. So we have talked about factoring before. Let's take this equation and let's factor it. So this one here would give us what multiplies to get -4, but add to get -3. And it would be x minus 4 and x plus 1. And if we were to set each of those equal to 0, we would get x equals 4 and x equals -1. So those would end up being my solutions or my roots. And so those 2 points here should have been on my graph, and you can see how poor of a job I did actually when I was graphing these, because it was supposed to go through those 2 points. So the x-intercepts here are at -1, 0 and at 4, 0. These 2 points here then would be your solutions to the equation. Okay, so option number 1 for solving is factoring. Option number 2 now is graphing if they ended up being nice. Now, just a quick review of other things here. Your y-intercept here, we already graphed of 0, -4. But then we do want to talk about decreasing and increasing. So this first half here in red, my graph is decreasing because it's going down. But then over here in black, this half here would be increasing because it's going up. And I stop decreasing and start increasing here at my x value of -1.5. So increasing starts, oops, should be a positive 1.5. So increasing starts at 1.5 and goes to the right, meaning my x's are getting more positive. Decreasing starts all the way at the left where my x values are negative and stops when x is 1.5. Increasing and decreasing always has parentheses. So we've seen a graph now with 2 solutions. What would something look like if it has 1 solution? Well, that means it has to have only one x-intercept. So there would be a point on my graph as my x-intercept, and that would actually be the only one. It would only cross it once. Whereas the next one, no real solutions, means that I can't cross the x-intercept or x-axis at all. I can have no x-intercepts. So this would be something that would have no real solutions. Or it could be your vertex could be above the x-axis and go up. So sometimes when we are trying to calculate the zeros or solutions, we have something that we don't necessarily know where those solutions are. And so that's what we kind of worked on a little bit yesterday with our calculator. We also want to show you how you can solve for the solutions for things that aren't necessarily quadratic. So it's going to be the same process of yesterday. So you go ahead and you type this into y equals and you take a look at the graph. Now this graph is not quadratic, it's a different type of function, but we can just draw a rough sketch here of what this graph looked like. If we wanted to solve the equation 0 equals this is again looking for your x-intercepts because it's looking for your zeros. So I can see that there would be 1, 2, 3 different solutions. So we wanted to practice that skill again of calculating those x-intercepts. So we're going to hit second calculate. We're looking for our 0. I'm just going to go left to right. I'm going to aim for the furthest left one. So I'm going to go to the left of that 0 and hit enter for my left bound. I'm going to go to the right of it and hit enter for my right bound. And I'm going to hit enter for my guess. So my 0 for this one happened to be at -1, 0. Again, my left bound was somewhere over there. My right bound was somewhere over there. I got -1, 0. So my solution would be x equals -1. So go ahead and try it again. For this next one here, your left bound would be somewhere up here above. Your right bound to the right would be somewhere down here. So go ahead and calculate that other 0. When you do that, you end up getting x equals +1/2. And do that one more time for this 0 over here. Your left bound would be somewhere here, and your right bound would be somewhere here. After you hit second calculate, your x-intercept should be 2, 0, so your 0 would be x equals 2. So because we can solve via graphing, you can solve using second calculate when zeros aren't so nice. An example of that is this problem right here. So we have something tossed from a helicopter at an altitude of 200 feet, and you can see this equation here representing that. T is our time. We want to know how long will it take the package to reach the ground. So if you imagine something on the ground, that means your height is going to be 0. So our equation, if we plug in our height to be 0, we get 0 equals -16t squared plus 28t plus 200. Now you first want to go and see if you can factor this. So this here, we could take out a GCF. We're going to take out -4. When we do that, we end up with something that we can try factoring by split middle term or guess and check. This does not factor. So here's where you want to go to your calculator to find the x-intercepts. So go ahead and type this in on your calculator. So we type in our equation into y equals and we hit graph and we get this. So what's happening here is our values are way too high. My y-intercept is up there at 200, so I'm going to change my y maximum to be somewhere above that, so like 225 or something like that. You should get a pretty good picture of your graph then. And we can see this is a parabola that opens downward, which means for our sketch, it looks something like this. Now we're looking for where our package hits the ground. We're looking for the x-intercepts, but this one over here would represent negative time. And so for this one, it's not in our context. We don't want that one. We only want the real ones, the positive values for time. So you can go ahead and hit second calculate. And when you do that and you calculate this 0 over here, you should get a decimal. So you try it first, pause the video, try it, and see what you get. We should get 4.52 seconds for that. So that is the only one we're looking for due to the context. So this equation that we had here represents your vertical motion model. The -16 out in front refers to the pull of gravity. There are two other variables. V0 or V sub 0, that's the initial velocity. So in this problem above, the initial velocity was 28 feet per second. The H stands for the initial height. So the initial height here was 200, and you can see that that was actually in the word problem there. For this next one, we're going to use this vertical motion model, but we have to plug everything in ourselves. So we have our initial velocity being 60 feet per second, which means it's going to be -16t squared plus 60t. We want to ignore the height of the person, which means the initial height here is going to be 0. So you could put +0, but I'm just not going to put that. We are now asked to solve for when the arrow will hit the ground. So once again, the height of the ground is going to be 0. So we plug in 0 for h of t. And this is no calculator. We want to find this 0. We want to find the solution. So we're going to go ahead and we're going to factor this. So if we're first going to take out our GCF of -4t. And so we get 4t minus 15. And we set each of those parts equal to 0. And we get t equals 15/4. And so the 0 represents it's starting at the ground, and then back at 15/4 or 3.75 seconds, it gets back to the ground.